Okay, hi everybody. Today we're going to be talking about gas laws and how to do some of the calculations of gas laws. So here we go. Our first law is called Boyle's law. It is going to be describing the relationship between pressure and volume. That means temperature and the amount of the gas remains the same. In other words, the amount of moles of the gas remain the same. Okay? So when volume increases in Boyle's law, then we are going to experience a temperature decrease. And then the opposite will also be true. When volume decreases, we'll experience a pressure increase. All right? So let's take a look at this inverse relationship. In other words, one goes up and the other one goes down. So here is our equation we are going to be using for Boyle's law. P1 times V1, in other words, pressure 1 times volume 1, will be set equal to pressure 2 times volume 2. So here's our example. In our example, a gas occupies 1.56 liters at 1 atmosphere. As you know, atmospheres are pressure and liters are volume. So we can go ahead and label this as our volume 1 and this one as our pressure 1. And I know it's volume because it has liters, and I know it's pressure because it has atmospheres. The question is, what will the volume be? So I want to know volume 2 if the pressure becomes 3 atmospheres, and that is my P2. So in my equation, I'm going to fill in my numbers. I have 1.56 times 1.00, and that's going to be equal to P2, which is 3.00, and I'm going to be solving for V2. Doing my math, I'm going to end up with 0.520 liters will be my V2. And that's how I'm going to be doing my math. For those of you that are going, okay, what did she do? I did 1.56 times 1 is equal to 3 times V. So I divided by 3 on both sides, and I got 0.520 liters. Okay, so at this time, I'd like you to try this on your own. You try. At a fixed temperature of 25 degrees Celsius. Since it says fixed temperature, we are not going to need to worry about that. It's going to stay the same. A balloon has a volume of 5.50 liters at a pressure of 101.3 kPa. If this pressure is increased to 202.6 kPa, what will be the new volume? This is going to be an answer you should record in your Edpuzzle. All right, our next law is Charles' law. In Charles' law, this is going to be a relationship between volume and temperature. In other words, in this case, volume goes up, temperature will also go up, and the same thing is true if volume goes down, temperature also goes down. That means that we have a direct relationship. What one does, the other does. So Charles' law is a direct relationship, and our equation can be shown as V1 times T2 is equal to V2 times T1. Now, some things that we need to remember about this is that temperatures must be in Kelvin, but this equation can also be written as V1 over V2 is equal to T1, remember it's in Kelvin, over T2, remember it's in Kelvin. And I kind of find this way of showing that same equation as a little bit easier way to remember. So go ahead and make sure you write both equations in your notes. Okay, and let's remind you, please, that temperature, to change it to Kelvin, you must add 273. All right. On Edpuzzle, go ahead and compare and contrast the relationship of the variables in Boyle's and Charles' laws, and then I want to know, what does a direct relationship or an inverse relationship mean? So go ahead and answer in your Edpuzzle at this time. The next is an example. What will the temperature be when 2.00 liters at 20 degrees Celsius is compressed to 1.00 liters? So for this, we are using Charles' law. You might notice in this type of problem that there is no mention of, no, it did mention volume. There is no mention of pressure. You might be reading this going, oh, where's the pressure? That means that we are going to assume that the pressure is constant. Okay, when pressure is not, or temperature is not, or volume is not mentioned, then we're going to have to assume that it is constant. So I'm going to use my Charles law, which is used when pressure is constant, which is V1 over V2 is equal to T1 in Kelvin over T2 in Kelvin. So I'm going to go ahead and put my volumes in there. I have 2.00 divided by 1.00 is equal to T1, which let's remind ourselves to add 273 to it. So T1 is going to be 293 over T2. And we're going to be solving for T2. So I'm going to cross multiply these. I'm going to end up with 2.00 T2 is equal to 293. So I'm going to divide by 2.00 on each side. And my T2 in Kelvin comes out to 147 Kelvin. If I had to take it to Celsius, I would end up with negative 126 degrees Celsius. That's if I subtracted 273. Okay, everybody, let's see if you can try this out yourself. Please record your answer in the Edpuzzle. All right, our next law is called Luzak's law, and it is the relationship is between pressure and temperature, and this time we will be keeping volume constant. And so in this relationship, temperature and pressure are, as you can see, directly related. When one goes up, the other goes up. Also, when one goes down, the other goes down. In other words, we have a direct relationship. Okay, so let's look at our equation. You'll notice that the thing that is being kept constant is not included in our equation. So this is going to be P1 over T1 is equal to P2 over T2. And so we will want to see if we can try an example of that. So in our example, we have, if a gas is pressurized from 15.0 atm to 16.0 atm, and its original temperature is 25 degrees Celsius, what would the final temperature be? Okay, so I'm going to label some things here. I have P1 and P2, and I have T1. Of course, we have to use these in Kelvin, and I'm being asked for T2. So here I go. I'm going to plug in everything. I have 15.0 pressure 1 divided by 298 for 25 plus 273 gives me 298 Kelvin. And on the opposite side of the equation, I have 16.0 divided by T2 in Kelvin. So in solving, I'll end up cross multiplying. So I'm going to have 15.0 T2 is equal to 298 times 16, 4,768. And then to solve, I'm going to divide by 15 on either side. This will give me my answer for T2 in Kelvin. 318 is what we're going to use. 318 Kelvin. If we change it to Celsius by subtracting 273, we will end up with 40. Let me make sure I do this right. 273, 45 degrees Celsius. Okay, let's have you guys try this on the next one. Please record your answer in your Edpuzzle. Now, you probably are wondering, well, what if we change everything? And even if you weren't, here's what happens. When we are changing everything, that means everything is changing. We need to know one missing variable. Then we have something called the combined gas law. This is going to be the relationship between all three variables. Okay? What it means when it says the amount is constant, we mean that the moles of the gas is constant. Okay. Our standard temperature, as you know, is 0 degrees Celsius or 273. And standard pressure, as you know, is all listed there. We have learned about those already. I bring those up again just so that you see them. All right, so let's look at an example problem. This asks us what is the final volume, V2, when volume 1, 3 liters of a gas, at pressure 1, 1.5 atmospheres, and temperature 1, I'm going to add 273, and this is going to be 298, and temperature 1 Kelvin is changed to a pressure of 2.5 atmospheres and 31 degrees Celsius, which is T2. In Kelvin, we get 31 plus 273 gives us 304 Kelvin. All right, we're ready to plug this all into our equation, which is P1 times V1 over T1 Kelvin is equal to P2 times V2 over T2 in Kelvin. And you might be wondering, why are we always doing this in Kelvin? That is because the scientists that investigated these laws did all of these calculations in Kelvin, so all of these equations are based solely on the relationship to temperature in Kelvin. So I'm going to plug in all of my numbers. I have P1 is 1.5. I have V1 is 3.0. I have T1, which is given as 298. On the opposing side, I have P2, which is 2.5. I'm solving for V2, that's my unknown, and my T2 is 304. So I'm going to cross multiply, which means I'm going to have 304 times 1.5 times 3.0 is equal to 2.5 times 298 times V2. Ultimately, I will divide by this product to find my V2. Okay, so when I calculate to find my V2, I end up with make sure I can write 1.84 liters. Yep, and that is my correct answer there. Of course, you need to try this yourself. So let's give this a try on the next one here. And let's go ahead and have you complete this one on your Edpuzzle. Our final law is called Dalton's law. And Dalton's law is for when we have a mixture of gases. So many times we have more than one type of gas in a vessel, and we have to add up the pressures of each of our gases to make a total pressure. Of course, all those gases must be in the same unit, so they all must be atmospheres or kilopascals or millimeters mercury or torr. All right, so here is our example. It says air contains oxygen, nitrogen, and carbon dioxide and small amounts of others. What is the partial pressure of the oxygen when the total pressure is equal to 101, and I lost my picture again, so 101.30 kPa, and then it tells us if N2 is 79.10 and 0.040 kPa for CO2, and then the last one is all cut off. So ultimately we would have, and I'm going to show you the setup of this since my problem is all off the side there. So I would have said that this number is 101.3. And my first one, which I'm going to make the N2, I would have plugged in 79.1 here. And then on this one, I would have made this my CO2 pressure, which 0.040. And then I ultimately would be O2, CO2. Okay, then it looks like there's a small pressure of others. So this would have been whatever the others were, and then we would have solved for the PO2. So let's pretend that we have 0.0001 for the others. So we're pretending right now because I can't see that bottom line. Ultimately, we would add everything together on the right-hand side and then subtract so that we solve for PO2. So when we do that, we end up with 101.3 minus 79.1 minus 0.04 minus 0.001. And we end up with 22.16, and the unit label was kPa. Okay, so let's have you give it a try, and I will tell you that on this last one, this is somewhat of a challenging question because it has unit labels of different pressures, and you are going to have to change the different pressures to atmospheres to be able to solve this problem. This is your final question on this Edpuzzle.